Welcome back, everyone. In this section, we get to talk about a very special topic in TypeScript, which is generics. Now, as you can see by my choice of stock art here of this confused, intimidated, scared woman, generics can be a little bit difficult to wrap your head around at the beginning, and it's not helped by the fact that they have a pretty nasty syntax, in my opinion. It's just ugly. That's not to trash them because they're very important. We'll use them all the time in TypeScript. You can't help but encounter them in the real world. But again, I think the syntax is clunky. Not that I could necessarily do better, but it just is something I've noticed in teaching this stuff people struggle with. So it's a combination of the concept being a little tricky and the actual syntax being a little tricky that makes it confusing at times. With that said, they are important, and we're going to make it through just fine. I don't mean to scare people away. It just takes a couple of steps to really recognize what they are and to see the value in them. So you might be thinking for the next couple of videos, yeah, this seems maybe not that useful, and that would be normal to think that, but hopefully by the end of the section, you can see some utility. Okay, so what are generics? In TypeScript, generics are a special feature, a special bit of syntax that allows us to define reusable functions or reusable classes that can work with multiple types. And you might be thinking, well, we already can do that, right? I can write a function that accepts multiple types, like let's just call it doThing, and it can accept thing, which could be number or string. We know how to do that. We can use a union type. That is not an example of a generic. It might sound similar with this definition, a reusable function that works with multiple types, but a generic is even more generic than this. This is saying number or string, but we could write a function called doThing that says we'll accept any type, and then whatever that type is will return that same type. So right now, I don't have a way of saying thing, if you pass in a number, will return a number. And if you pass in a string, will return a string. I can say this function will return a number or a string. And then in here, we have some logic that decides which one. But you don't know from looking at this function what you'll get out. If you give me a number, maybe you'll get a number back, maybe you'll get a string. All that this says is the function accepts a single number or string and then returns a single number or string. But I could write a generic function that says, if you give me a number, I return a number. If you give me a string, I return a string. If you give me a Boolean, I return a Boolean. So we abstract the type away even further. And like I said, you'll have to bear with me because that is very confusing sounding. But let me show you an example of a built-in generic we've already seen. Think back to our array types early on. We talked about, if you want an array of numbers, you need to annotate it, if you have an empty array at least, because TypeScript doesn't know what type this empty array will eventually hold. It just knows that it's currently empty, so it says that's of type any. But we could annotate it and say, no, this is a list or an array of numbers. And we use a special syntax with the type followed by array brackets, but then maybe you remember I said there's an alternative syntax that looks like this. I pointed it out at the time where we have array with a capital A and then angle brackets and a type inside of that. So this array right here is a special type. You can see it's an interface array, and then the type that the interface definition has this capital T, and that's just standing for some type. This is an example of a generic. You just provide some type to it, and then what does it do? It will return to us an array type of numbers in this case, right? A type for a number array, or I can do this, array of string, and that should give me a new array type of strings. So I could call or make, const colors is of this type, and it starts empty. But it only allows strings in there. As soon as I put a number in, it's not allowed. So the syntax, one more time, is the name of our interface. In this case, it's array. We didn't write that, but that's the name of it. And then we must provide a type in there, string, number, Boolean. It could be some other thing that we've made. It could be another interface called cat. It could be a union type. Whatever it is, we provide it inside those angle brackets. And this is essentially a factory for array types. It's written in a generic way to accept any sort of type, and then it can return a new type based on that. If you give it a string as a type, it will say, all right, here's an array of string type. If we give it a Boolean, it generates a Boolean array type, if that makes sense. But we have this cleaner syntax that's far more common. We get this shortcut, and that's what most people like to use. But behind the scenes, this is another option. So this is just our first example of using a generic. We didn't write this generic function or class or interface. We're just using it. And to use it, we provide a type inside those angle brackets. So if you're lost, that's totally normal. In the next video, we'll take a look at another built-in generic and play around with that. So we'll get some more practice before we actually try and write our own.